Hey class, right now I want to go over the first side of the AP Physics 1 equation sheet. You didn't use this side a whole lot throughout the year, but there are a small amount of things that are important to you that you need to know for your test. First thing you need to know is the universal gravitational constant. That was when you were doing force of gravity between two large objects like planets and moons. And the formula on the other side is Fg equals gm1 times m2 over r squared. And g is a constant, which is 6.67 times 10 to the negative 11th. Below that, you need to know 1 atmosphere of pressure is 1 times 10 to the 5th, or 100,000 pascals. In the equation, P equals PO, or atmospheric pressure, plus rho GH. The P sub O is the atmospheric pressure, which is the 100,000. When we have objects on Earth and we do Fg equals mass times gravity, well, the equation sheet says to use G equals 9.8, but all the equations on AP Classroom and everything I've seen use 10. All the other teachers I know use 10, so I would use 10 as the acceleration due to gravity, and that'll make calculations go quicker because a lot of times they'll make answers whole numbers, and using 10 will make that work out really easily. If you need to convert, well, we've got prefixes right here. You shouldn't be converting a whole lot, but they're there for you. I imagine 1 meter equals 100 centimeters is probably going to be one you may have to use on your AP test. Over here we've got our symbols in case you need them. Over here we have our trig functions. I would just make sure that you are in degree mode. The only time you need to be in radian mode is if you're doing any sort of graphing for the simple harmonic motion part of the chapter. But they're there for you, but you probably won't need it because you could just type sine of 30 or cosine of 45 right into your calculator, and as long as you're in degree mode, you should be fine. Here's just some things that you've seen on our tests, which is basically air resistance can be ignored, friction can be ignored. Springs and strings are ideal, meaning that they have no mass, so you don't put them into your calculations at all. Fluids are ideal, they don't change density. So all the things we've talked about before and things you can kind of just ignore to make the problems work out the way they're supposed to. And then we got geometry and trig on the bottom here. Obviously you guys probably know Pythagorean theorem here on the right, but it's there in case you forgot. There's some areas, volumes, surface areas down here. I imagine out of all the ones that are down here, probably if you're doing density and you've got a sphere, the volume is 4/3 pi r cubed. That would go down here in the denominator for density equals mass over volume. I guess I should use the rho for density equals mass over volume. And then one other thing that you might need to know is that S equals r theta. That is if you are looking for a certain arc length of this circle, that is equal to the radius here times the angle theta. I know when I taught those, it went along with V equals R omega and A equals R alpha, but those are on the other side, which I will get to in the next video. So those are the most important things. I will make a video or two more on the other side. Thank you.